Hello, welcome to Algorithms. My name is Saurabh. Today we are going to discuss about energy supply optimization architecture on Azure platform. We all know that grid optimization is more than a hot industry buzzword. It encapsulates demand response, the management of distributed energy resources, and the implementation of non-wire alternative programs into modern integrated programs. Okay, so let's get into it. This is the basic definition that why we need energy supply optimization techniques and the digitization. Okay, so what we are trying to say here is that an energy grid consists of energy consumers as well as various types of energy supply, trading, and storage components. Like substation accepts power load or exports excessive power. Batteries discharge energy and store it for the future use. Wind farms, solar panels, which are more of a self-scheduled generators, micro-turbines, which are dispatchable generators. The demand response bids can all be engaged to satisfy the demand from the consumers within the grid. Now, given all the constraints that we have on this kind of architecture, grid architecture, a central challenge the smart grid operator that faces nowadays is how much energy type of each resource should commit over a time frame so that the forecasted energy demand from the grid are satisfied. This is the basic challenge, and this is what we are trying to address, that how we get the accurate demand prediction so that right supply can be made at the right time. Okay, so we need to create that balance from the supply side. So let's have a look. This is a basic statistics that I captured from the internet. By 20 to 35, energy consumption will increase by 35%. So we need to make sure that we have the right techniques and architecture in place from the digitization perspective to ensure that we are able to calculate those demands using the right or appropriate energy resource optimization techniques. Okay, challenges in leveraging energy resources is because the number of resources are increasing day by day, and when and how long to access resources, how to maximize profit margins, and knowing the energy demand. Now, challenges in implementing energy resource optimization is getting data from multiple sources. Now, once you receive the data, how are you going to interpret it in a meaningful way? Now you have to put a dashboard on top of it or some type of visualization in order to get optimization recommendations in the format which can be easily understood by the executives. Okay, and then validating the solution. Now, whether the forecast or the resource optimization being addressed by the specific algorithm or a specific architecture, is it accurate or not? That's another and important challenge. Now this is reference architecture. Uh, you look at what are the components being used. So this solution provides an Azure-based smart solution. I would say smart solution because there are so many things which we are using, which are not, which are, I would say, open source. Okay, and I'll explain about the mathematical model used in this reference architecture, just so that you know uh, that how that mathematical model is integrated with the existing architecture and how it is being utilized. So that's the reason I'm calling it Azure based smart solution. So the reason is how we determine the optimal energy unit commitments from various type of energy resources from an energy grid. So our goal is to minimize the overall cost incurred by these commitments while satisfying the energy demand. So so now when we look at the technical details and workflow, so the sample data is streamed by Azure Web Jobs. The web jobs are using resources related to data from Azure SQL to generate the simulated data. The data simulator feeds this simulated data into Azure storage and writes message in the storage queue. That will be used in the rest of the solution flow. Another web job monitors the storage queue and initiate Azure batch job once message in the queue is available. The Azure batch service together with the DSVM, which is data science virtual machine, is used to optimize the energy supply from a particular resource type given the inputs received. So, and then the other item or service is the Azure SQL database is used to store the optimization results received from the Azure batch service. Now, finally, Power BI is used for results visualization. Now, if you would like to look at the actual solution architecture, so this is what I just explained from the component perspective. Web jobs, Azure storage queues, Azure batch, and Power BI dashboard. Now, one important aspect I mentioned about data science virtual machine. So, what we are doing here is we are using a mathematical model for energy resource optimization. And if you have heard about mixed integer linear programming, which is one of the most widely used mathematical optimization models in the industry. So given a time horizon over which the model aims to optimize, the model accepts the forecasted demand, forecasted self-scheduled generation, and forecasted prices for substation, inward load, substation, outward sale, battery generation, battery charge, demand response generation, as well as dispatchable generation. All the elements that I explained in the earlier part of the presentations when I mentioned about different sources. Okay, so those are the inputs. Now, model also considers various physical and business constraints to which each resource type of the resources must comply, because if we have different types of input, if we don't specify the physical and and the business physical characteristics and the business constraints, the outcome will not be the best outcome. Means it will not be the it will not be an appropriate outcome or something which is way off from what we are expecting. So then model computes the amount of substation load or sale, battery generation or charge, demand response generation, and dispatchable generation that yields the minimum cost in fulfilling the demand. So overall the model contains a MILP objective function and a number of integer linear constraints whose exact amount is determined by the amount of the resources. Now this last part was little complex and it was not meant for the enterprise architects or solution architect. It was meant for data science data scientists and those who are dealing with the artificial intelligence or machine learning or statisticians, because they are the ones who actually work on these algorithms. And then, because since I mentioned about data science virtual machines, and these virtual machines come with these models or packages, so I just wanted to make sure that those aspects are covered and you understand as well. Though I am not going to go deep into the MILP part because that's not objective of the presentation, but since I was requested in previous presentation to make sure that I include some details, so people who are working on these projects, they can go back and they can do some more research. I guess this is it from my side. If you guys have any questions, please let me know. Drop your comments in the comments box and like the video. If you have any specific requirement, or if you want to see any specific presentation on this topic, please let us know as well. Thank you very much. Have a great day.